Hello everyone. Let's begin our journey into physics with a simple question. Have you ever looked at the sky and wondered why the sun rises every day, why seasons repeat, or how the moon always follows its path around Earth? These are not just poetic thoughts, they are physics in action. The very word physics comes from the Greek word physis, meaning nature. So physics is essentially the study of nature and its phenomena. Similarly, the word science comes from the Latin word scientia, which means to know. When we put these together, physics becomes the subject of studying nature and natural phenomena in a systematic way. From the ancient curiosity of humankind to today's advanced science, every observation, like sunrise, tides, or motion of planets, has contributed to physics as we know it today. Science, in its true spirit, is nothing but accumulated knowledge about the world around us. This knowledge grows as it passes from one generation to the next. Each generation adds something new, and so the picture becomes clearer. Think of it like a relay race. One scientist hands the baton of discovery to another, and together they build the ever-expanding field of physics. For example, the falling of an apple inspired Newton's laws, which later paved the way for Einstein's theory of relativity. Science thrives because theories are tested, improved, and sometimes even replaced with better ones. Now, how do we gain this knowledge systematically? That's where the scientific method comes in. It's like a recipe for discovering truth. The first step is observation of facts. For instance, Newton observing an apple fall. Next, we move to proposing a theory or hypothesis. Newton suggested that gravity is responsible for the fall. Then comes the most crucial part, testing predictions. If the theory is correct, it should hold true for other cases too, like planets revolving around the sun. Finally, there is modification of the theory. If new evidence contradicts the old idea, the theory must evolve. That's how Newton's classical mechanics gave way to Einstein's relativity when we observed objects moving close to the speed of light. All these steps together ensure science is never static but always refining itself. Now comes the exciting part, the scope of physics. Physics spans unimaginably vast ranges of length, mass, and time. For length, imagine this, the size of a nucleus is about 10 to the power minus 15 meters, while the size of the observable universe is about 10 to the power 26 meters. That's a difference of 41 powers of 10. For mass, we range from the electron at about 10 to the power minus 30 kilograms to the mass of the Sun at 10 to the power 30 kilograms. Time too stretches across extremes, from nuclear reactions that occur in 10 to the power minus 23 seconds to the life of the Sun, which is nearly 10 to the power 18 seconds. So you see, physics handles both the infinitely small and the infinitely large with equal precision. How does physics manage to explain such a vast universe so elegantly? There are three key reasons. First, regularity and symmetry. Natural phenomena show patterns. Day follows night, and seasons repeat, patterns that physics captures mathematically. Second, even the most complex events obey simple rules. For example, the law of conservation of energy states that energy can neither be created nor destroyed, only transformed. This one law explains everything from a child's swing to the working of power plants. Third, in any complex situation, we can separate important features from minor ones. Think of studying projectile motion. We ignore air resistance initially, and yet we get a reliable prediction of motion. Later, we can add complexity. This ability to simplify is what makes physics powerful. Let's try an example to appreciate the scales we just discussed. Question: how many times greater is the mass of the Sun, about 10 to the power 30 kilograms, compared to the mass of an electron, about 10 to the power minus 30 kilograms? Step 1. Write the ratio. Mass of the Sun divided by mass of the electron equals open bracket 10 to the power 30 close bracket divided by open bracket 10 to the power minus 30 close bracket. Step 2. Simplify the powers of 10. That gives 10 to the power 30 minus open bracket minus 30 close bracket, which equals 10 to the power 60. So, the mass of the Sun is about 10 to the power 60 times greater than the mass of an electron. This single calculation shows how physics elegantly handles unimaginably vast numbers with the help of exponents. So, let's quickly recap. Physics is the study of nature and natural phenomena built on observation, theory, and experimentation. The scientific method ensures that knowledge is tested, refined, and sometimes even revolutionized. The scope of physics stretches from the tiniest subatomic particle to the vastness of the universe across extraordinary ranges of length, mass, and time. And why does it succeed? Because natural events have patterns, simple universal laws, and separable features that make even complex processes understandable. I hope you now see physics not just as equations and definitions, but as a grand narrative, a story that explains both the fall of an apple and the motion of galaxies. See you in the next session with another fascinating concept of physics.